All right. Hey, the last section here today, we're going to talk about making a scatter plot, finding a line of best fit, and then doing a couple of things. One of the things we'll be doing with that is called interpolation, or we're going to interpolate. There's another word we're going to look at, it's called extrapolation, or extrapolate. And then we'll mention very quickly finding the zeros of a function. All right? So I've given you right here a bunch of ordered pairs that describe professional football players, the average salary in a certain year. Okay? And 585 actually stands for 585,000. So in 1997, the average football player made $585,000. In 2001, the average player made $986,000, almost $1 million. All right? So let's make a scatter plot of this, okay? And we'll just, I'm just going to kind of start, I'm going to call this first thing right here 1997, 98, 99, 2000, 2001, and then we've got to go from 585, from 500 almost to, let's see, 500, 600, 700, 800, 900. That would work, wouldn't it? 500, 600, 700, 800, 900, and then this would be 1,000 or $1 million is what that would, 1,000, which would be $1 million. Say that, figure that out. So in 97, it was $585,000. In 98, we don't know. In 99, it was $708,000. In 2000, it was $787,000. And in 01, it was $986,000. Okay? And so we can make that scatter plot, and then we can probably draw what we would consider to be our line of best fit through that. Okay? Yeah, our line of best fit. And when I do that, when we draw that line of best fit, I kind of think that I drew my line through this point and through the 1999 one. Does that make sense? All right? So let's use those 2 points. This would be 1997, 585, and this one, which would be 1999 and 708. Let's use those to figure a line of best fit, an equation. Okay? We've got ordered pairs, so let's find our slope. Slope means 708 minus 585 over, can I just go 99 minus 97? Is that okay? All right? And you'll want to get a calculator, but if you can remember how to do this, this is called subtraction. Maybe you've forgotten that. That would be 123 over 2. Let's go ahead and divide that out. Again, this is something that's called division. All right? Not sure if you're familiar with that, but we could call the slope 61.5, and I think it's okay that we use a decimal here. So using this slope and one of these points, let's write ourselves an equation. All right? Let's use this point right here. Okay? Y minus 585 equals 61.5 times x minus 1997. All right? Does that make sense? We found the slope. We used the slope and a point to write the equation of a line in point-slope form. Now, we're going to use this equation to do what we talked about a little bit ago. We're going to interpolate. We're going to try to figure out a number somewhere in between the data that we already have. Now, there's only 1 year missing from the data we have in here, and so let's try to find out what was the average salary in 1998. Well, if we're going to do that, guess what we're going to put in for x? 1998, that's right. So y minus 585 is going to equal 61.5 times 1998 minus 1997. That's y minus 585 equals 61.5. What's 98 minus 9? That's 1, isn't it? And what's 61.5 times 1? 61.5. So all I have to do to get my final answer is add 585 plus 61.5. Here's another idea that you might have forgotten or never known about. It's adding decimals together. Okay? 6, 4, so 646. So we would say that in 1998 the average salary was $646,500. Okay? Well, that's called interpolating because you're figuring something that's inside what we're looking at. All right? Now, if we go to the next idea, extrapolating, I want to use this same equation. Y minus 585 equals 61.5 times x minus 1997. Extrapolating means finding something outside of the area you were dealing with. Our chart went from 1997 to 2001. So give me a year that's outside of that range. Well, okay, how about 2005? Let's try to find out what the average salary was in 2005. What are we going to do with 2005? That's right. We're going to put it in for x. So y minus 585 equals 61.5 times, isn't that 8? Mm-hmm. And then this is something, I don't know if you guys know what this is. It's called multiplication. 8 times 1 is 8, plus 4 is 12. Yeah. You carry the 1. 8 times 6 is 48. It's 49. You 1 decimal place it. So that's really going to be y minus 585 equals 492. How do I solve for y? I add 585, and I get, let's see, 7, 17. Wow. So is that right? 9, 10? Yeah. So in 2005, they were looking at making the average salary $107,700. I'm sorry, $1,077,000. Yeah. Whew. 100,000 is a million. All right. So that's called extrapolating. All right? All right, very good. Now, the last thing in this section that they're going to ask you about is actually finding zeros of a function. All right? Finding the zeros of a function. Well, the zeros of a function are actually the x-intercepts. So if I was to give you an equation like y equals negative 0.045x plus 5.7, and I ask you to find the zeros of this function, well, to find the zeros of a function, you put a 0 in for y. Okay? And then you solve for x. Let's subtract 5.7. So negative 5.7 equals negative 0.045x. How do I get x by itself? Divide by negative 0.045. All right, I'm not going to do this one by myself. I'm actually going to go find my calculator here. All right, here, calculator. Where are you, calculator? There you go. All right, so let's do that. Let's do 5.7 divided by 0.045. It's 126.66, and maybe we should just call it, let's just round it. We'll round it to 2 decimal places, all right? So 126.67. Is it going to be positive or negative? There's a lot of negative signs there. Oh yeah, negative divided negative is a... So the zeros of that function are 100, it's 100, the zero is 126.67. So if you want to find the zero of a function, put 0 in for y. All right? All right, good luck with that. We'll see you.